So, hi everyone, we're back, and today we're looking at the binomial theorem in Pascal's triangle. And the first thing that they want you to do is this warm-up, and they are asking that you take each of these and expand them. So, why don't you go ahead and pause the video and see how far you can get, and just instantaneously, without stopping to look things up or to build a set of boxes to multiply things. So I'll wait while you pause. Alright, I'm assuming that you got to a certain extent. I think the ones that are kind of right up at the top here are the easiest. Anything to a zero power is 1. So that's just going to be 1. I'll get the brush size a little bigger. So anything to a zero power is 1. And then anything to a first power is just itself. So that would be x plus y. All right. Note exponent 1, 2 terms. Right here, this you have to actually multiply to itself. So I hope that you didn't just square x and square y and that's it. So you would just write it twice, and then you do FOIL on it. So that's x squared plus 2xy plus y squared. And there is no possible way that I'm going to start listing this 3 times and multiplying them, but I'm going to show you what a little bit of experience with this can get for you. So I know that this is going to be x to the third plus 3x squared y plus 3xy squared plus y to the third. Note that we're seeing the exponents decrease 3, 2, 1, and then finally you can actually write an x to the 0 power. And the y exponents are increasing. So this would be y to the 0, y to the first, y to the second, y to the third. But then you have these coefficients, 1, 3, 3, 1. All right? I happen to know those coefficients, and I happen to know the pattern for how the exponents for x decrease and the exponents for y increase. So let's go ahead for the next one, because I know this pattern too. This will be x to the fourth plus 4x to the third y plus 6x squared y squared plus 4x y to the third plus y to the fourth. Again, the x exponents are dropping from term to term by 1. The y exponents are increasing by 1. And that's just a matter of knowing these coefficients. In fact, I can go ahead one better. So x plus y to the fifth, that will be equal to x to the fifth plus 5 x to the fourth y plus it would be 10 x to the third y squared plus 10 x squared y to the third plus 5 x y to the fourth plus y to the fifth. Same sort of pattern, but where in the heck do these coefficients come from? Well, obviously they come from writing this out 5 times and then multiplying and multiplying and multiplying and multiplying. But we've got a quick little way to go about this, and it's going to be employing this genius thing that Pascal came up with called Pascal's Triangle. And it is a convenient way to remember how to get those coefficients. So you start out like this. Okay, you just start out with a 1. And remember that that was that binomial expansion raised to the 0 power. So we'll just kind of note that there. And then you go with another set of 1s, right? And that's when we had x plus y to the first power. That was 1x plus 1y. Now the fun starts. Put a 1 down, and then add these two together, and then put another 1 down, all right? Remember, x squared plus 2xy plus y squared, all right? That was when we were squaring. And keep going like that. 1, and then add these together, 3, add these together, 3, and then another 1. And that was when we had cubed that binomial, and then a 1, a 4, a 6, a 4, and a 1. That's when we raised it to the 4th power. And you can go back up here and confirm that. See that? 1, 4, 6, 4, 1. It's nice that I knew that. Made things a lot easier. And continuing. 1, 5, 10, 10, 5, 1. All right, that was when I raised my binomial to the 5th power. And we can just keep going like this. So 1, 6, 15, 20, 15, 6, and 1. Of course, raising to the 6th power. 1, 7, 21, 35. Let's see, did I get that right? And that'll be another 35, a 21, a 7, and a 1. That'll be raising to the 7th power. Now, I will be honest, I do not have anything beyond the 5th expansion level memorized, but I could get to the next one pretty easily. And let's just round this out and get to the 8th. We're raising things to the 8th power. Your coefficients will be the 1, and then 8, 1 plus 7, then 28, and then 56, and then 70, and then 56, and 28, and 8, and 1. And that would be raising to the 8th power. So, pretty powerful thing. And there are patterns that go down the diagonals, and it's just an amazing, amazing little feature that math has going for it. So at some point you might want to Google this thing and see what all you can accomplish with it. But definitely picking out coefficients is an important thing. So that fills out that page. Need to pause to get the next page. So stand by. Alright, so we made the conversion to the next page in no time at all. So how do you apply this in order to get these expansions going? Get your wrist nice and loosened up, because there's going to be a lot of writing here. So it says use Pascal's triangle to help expand the binomials, and we're starting out with a 5th power. If you look down your Pascal's triangle, that was 1, 5, 10, 10, 5, 1 for your coefficients. So watch how this actually works. We'll start out with the first coefficient, that's 1. And then we take that first term, x, and we raise it to the 5th power. And then we take the second term, which is 1, and we'll raise that to the 0 power. All right? So then we will continue. Everything is plus, so we don't have to worry about signs. So then we'll have a coefficient of 5. We'll multiply that to x to the 4th power, and then 1 to the 1st power. All right? The 1 is sort of superfluous. It's not going to really add anything, but it's just giving you a pattern that when you get down to, say, something like letter B, you'll be following it, and you won't just get a superfluous outcomes. All right, so then the next coefficient is a 10, and we'll multiply that to x, and we'll drop it down 1. We'll see 5 to 4, and then it goes down to 3. And then we'll have the other term here, 1, and that'll be raised to the 2nd power. See, that's going from 0 to 1 to 2. And also the sum of these things. That adds up to 5, that adds up to 5, that adds up to 5. So continuing, we have another 10. And this will be x squared, and 1 to the 3rd power. Again, that adds up to 5. Plus the next coefficient would be 5 times x to the 1st power times 1 to the 4th power. Doesn't matter if it's inside or outside. And then plus 1, and that'll be x to the 0 power times 1 to the 5th power. Ooh, almost ran out of room. So let's see what we end up with here. This will just be x to the 5th, right? And this will be plus 5x to the 4th. Not too much going on with that piece of it, so it's not going to change much. Plus 10 x to the third plus 10 x squared plus 5 x plus 1. All of these things are equal to 1, so 1 times itself is just 1. And that is exactly what that expansion gives us. It certainly is a time saver in my mind, because you don't have to write this binomial out 5 times and then throw it in boxes or FOIL it, or long multiplication, whatever. It just could be quite out of control. So we're going to go ahead and do letter B the same way. It's going to be a little hard to fit this from left to right, but let's give it a shot anyway. And so you're raising this to the 6th power, and going back to Pascal's triangle, the coefficients you're looking for are 1, 6, 15, 20, 15, 6, and 1. And you can see there's a symmetry here, which helps out a lot. So let's just go ahead and expand this thing out. And I think I'll start way over here to try to fit things in. So we'll start out with our coefficient 1. And then we'll start out with this term, a, and we will raise it to the maximum that it can be, 6. And then we'll take this other term, which is not a 1, so it's going to add some substantial pieces to this. That'll be negative 2b to the 0 power. That has to add up to 6. Plus, all right, this will be 6 is our next coefficient, times a raised to the 5th power, and then negative 2b raised to the 1st power. So things are going to kind of go, this would have been a positive outcome, this will switch to negative because of that sign, and we'll see some alternation that way. All right, next coefficient is 15, and that'll be a raised to the 4th power, see it drops, and then negative 2b, and that'll be raised to the 2nd power. And that'll go back to positive, so plus, and our next coefficient is 20, and that'll now be times a to the 3rd power, and negative 2b to the 3rd power, has to add up to 6, and then plus, we're dropping down, 15, a squared, and then negative 2b, that'll be to the 2nd power. I knew this was going to happen. I'm running out of room. So I'm just going to kind of continue right here. And so the next term will be 6 times a to the 1st, and then negative 2b raised to the, whoops, I have a mistake here. Let me fix that. That should add up to 6. So that should be a 4. My bad. And then finally, this will then go up to 5. And then finally, plus a 1 times a to the 0 power, so that's kind of not going to contribute anything. And then negative 2b to the 6th power. So everything adds up to 6. That does, all the way through. Okay, so sorry that this has to go down between a couple of lines, but let's go ahead and condense this into one thing. All of this here, this term, that's a 1, that's a 1, that should just be a to the 6th. All right? So now we have a negative 2 times 6, so that should be a negative 12, a to the 5th, b. All right? And now this will be 4, right? Positive 4 times 15, I believe that would be 60. So plus 60 for the ultimate coefficient. And then we have an a to the 4th and a b squared. Right? So positive, negative, positive. The next one will clearly be negative. So this will be 8 times 20, and I believe it's actually negative 8 times 20. That'll be negative 160, a to the 3rd, b to the 3rd. All right? And that would be this term right here. So going on, the next one should alternate back to positive. That'll be 16 times 15, and I believe that'll be 240, a squared, b to the 4th. And now we're down to this one here, all right? So that'll be negative 32 times 6 is negative 192, and that'll be a b to the 5th. And what do we have here? This is going to be 64, right? 2 to the 6th, negative 2 to the 6th will be 64. That's a 1, that's a 1. So that'll just be plus 64b to the 6th power. And there is your monster binomial expansion. Pretty neat, huh? Yeah, it sure beats writing this guy 6 times. So, what do you think? Let's move on. And we're going to do a letter C here. And this is going to be to the 4th term. And just we can use for this that row of our binomial expansion 1, 4, 6, 4, 1. So 1, 4, 6, 4, 1. So those will be our coefficients, at least as we process each term. So let's start. I may be able to fit that here. Let's try. So your first coefficient is a 1. And, I mean, I'm listing everything here because it's notes. You may opt out of the things that are just kind of going to vanish. But in any event, this will be 3x raised to the 4th power and 4y raised to the 0 power. All right? Everything is positive, so everything will be plus in between. 4, and that'll be 3x to the 3rd power and 4y to the 1st power. Adds up to 4. Plus 6 times 3x to the 2nd power, 4y to the 2nd power. And darn it, I don't think it'll fit. I should have gone down a row, but whatever. All right, so then plus 4 is the next Pascal's coefficient, and 3x to the 1st power, put a 1 there, and then 4y to the 3rd power plus, and here's the last term, that'll be a 1 times 3x to the 0 power, so it goes away, and then 4y to the 4th power. So let's put that all together. All right, here, 3 to the 4th is 81. Everything else is a 1 except for the x, so that'd be 81 x to the 4th. All right, good start there. All right, now things are going to get kind of squirrely. So we're going to have, this will be a 27 times 4 times 4, and that should be 432 x to the 3rd y. All right? And then the next one may get even worse. That's going to be 9 times 16 times 6. And according to what I have, that's 864 x squared y squared. All right. Then it's going to be plus 768. Sorry about that running so close together. In fact, let's clean that up. So 768 x y to the 3rd. And then finally, I believe 4 to the 4th is 256. Everything else is a 1 except the y. So plus 256 y to the 4th. All right? And so that's how it's done. Now, another way to find the coefficients of a binomial expansion, as it says down here, is through the binomial theorem given in the box below. Well, that's on the next page. So let's pause ever so briefly, and I will go ahead and go back, and we'll open up on the 3rd page as if by magic. So this is supposed to be overwhelming, but relax. It says up here to relax, so I guess we ought to follow the directive here. And get this where I want it. We're going to actually apply this theorem more in the next day's notes, but for right now, I do want to kind of get this introduced somewhat. And it is a little bit scary, but let's just go for it. We're going to be making calculations without applying a complete expansion of the binomial. In other words, they'll say, all right, here's something raised to the 8th power. I want the 3rd term. And we're going to employ something here that's right here called combinations. Some of you may have seen this, some of you may have seen this before. There are two ways to represent it. There is n things taken two at a time, or n choose r. It can be written this way. This is not a fraction, so no fraction bar in between. And it employs our old friends, these factorials. It's just n a factorial over n minus r factorial times r factorial, and it'll answer the question, how many ways can I choose so many things out of so many? Okay? And that's going to help us get those Pascal coefficients without knocking ourselves out. So anyway, here's your binomial theorem. It's using combinations. And by the way, see your teacher for calculator steps. Because even those little dinky calculators have combinations in them. All right, but I can't show you this on the video because I'm not under camera. So when you expand a binomial, n things taken r at a time will represent the coefficient of the term n minus r times y to the r power. Now remember, if you look back at some of these expansions, when we raised things to the fourth power, we had 5 terms. When you raise things to the sixth power, you have 7 terms. There's always an extra term, mainly because in the first term, your third piece, coefficient, first piece, second piece, that second piece rather, I guess it would be third, it's going to be to the 0 power. And then, let's just say that's the y term. It'll be to the 0 power. And then at the end, you'll end up with an x to the 0 power. So you're always going to have one term more than the exponent on your binomial expansion. So there'll be n plus 1 terms in the expansion. So this formula gives you the coefficient of the r plus nth term. So you'll see it as we develop it. So we're supposed to go ahead and use combinations in order to just practice with them. You will be using calculators because oftentimes these things are kind of crazy. So this is one notation for it. Another way to write it is 10 things choose 3. So C is for combinations, but you might actually relate to it a little better if you call it choose. So let me just scoot this down so you can kind of see the formula for it. All right. Remember, this upper piece here, or the one on the left, is n. So we can write that on the numerator, in the numerator rather, as 10 factorial. Then we want the r is the 3 here. This is the r. So we want n minus r, that'll be 7 factorial. And then times r factorial would just be your 3 factorial, all right? And the easiest way to handle this would be to try to do some canceling. So we can say that the 10 factorial will be 10 times 9 times 8 times 7. And I'm going to quit there and call it 7 factorial, just abbreviate it, because I have a 7 factorial below that'll cancel out with. And then your 3 factorial is 3 times 2 times 1. Okay? So looking at this, gone. The 3 can take out your 9, leaving 3. Your 2 can take out your 8, leaving 4. So that should be 3 times 4 is 12, and 12 times 10 is 120. And what we're saying here is that there are 120 ways to have 10 choose 3. 10 people choose 3. Right, that's what combinations do. All right, so the next one is 8 choose 2. Or in terms of the other notation, it's 8 here and 2 here. Remember, no fraction bar. So n is 8 and r is 2. So that'll be n factorial over n minus r factorial, that will be 6 factorial, times r factorial, which will be 2 factorial. And if you follow this process here, you're going to want to expand your 8 factorial down to 6 factorial. So let's just go to 8 times 7 times 6 factorial to get a match with this 6 factorial. And then the 2 factorial is just 2 times 1. All right, so gone, gone. 2 goes into 8, leaving 4. And that's it. So 4 times 7 will give you 28. And again, just so that you know what this means, that means to choose 2 out of 8. There are 28 ways that you can do that, right? 120 here, 28 here. That looks a little like a 7. That's better. Okay. All right, so now it's 7 things choosing 7. I think there may only be one way that you can do that. So let's just go ahead and write that out. Remember, this is going to be 7 choose 7. All right, so n is 7, 7 factorial over 7 minus 7 would be, that's n minus r, 0 factorial, which we all know to be 1. Remember, just remind ourselves, 0 factorial is 1. Over r factorial, which is 7 factorial. That's just 1. This reduces to 1 over 1. That's 1 over 1. Ugh, terrible. Gone, 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 gone. All right, let's try to fix that a little bit. So that's 1 over 1. So your answer is just 1. There's only one way to pick 7 things out of 7. Okay? All right, but what I want to do here now is maybe to help you out a little bit with some linkage. This is a little extra. I want to kind of show you how you link all of this to Pascal's triangle. All right, so let's just call this linking Pascal's triangle to combinations. Or and combinations. All right, so this is kind of what we're going to do here. All right, so first of all, let's kind of write this out. Remember, 1 and then 2 1s and then a 1 2 1. Remember, that was for the 0 power. This is for the first power. This is for the second power. Then 1 3 3 1. All right, that'll be to the third power. And then 1 4 6 4 1. That was when we expanded by raising to the fourth power. And then I'm only going to go this far. 1 5 10 10 5 1. All right. If you do combinations here, okay, that's going to represent this. And if you do combinations here, it'll represent this. Whoops, that's not what it represents. Let me take that one number off. All right, it's going to represent this. And 10 can be calculated 5 things, 5 choose 2. And 10 can also be calculated with 5 things, choose 3. And 5 can be calculated as 5 things, choose 4. And then 1 can be calculated as 5 things, choose 5. So we can figure out these coefficients just based on substituting, doing them by combinations. So pretty nice. So over here, let me give you one example. I don't want to jump the gun. We're going to look at this more tomorrow. But let's start out with this question. Find the fourth term of this expansion. This will be 4. Let's call it 4a minus 3b and that'll be raised to the 8th power. All right? Remember here that n is 8. And what we want to do is find what r is. And remember, this right here is your r plus 1th term. So r plus 1 equals 4. That means that r is 3. Okay? Now if you look up here, that will be the exponent on the term that's kind of the second part of your binomial, right? And remember that the exponent on your first part and the exponent on the second part have to add up to n. So let's go ahead and we'll start out with the coefficient part, and we'll just go ahead and do it with combinations. So that's 8, choose 3. And that'll produce a number in your calculator, which will then multiply to 4a, that's the first piece of it, and that's the n minus r power, so that's 8 minus 3, which will be 5. And then the second term, or the second part of this binomial, that's negative 3b to the r power, which will be 3. So 8 things taken 3 at a time, or 8 choose 3. If you do that in your calculator, which I hope you can try yourself after you figure out, or your teacher shows you, that'll be 56. So that'll be 4a to the 5th power times negative 3b to the 3rd power. Miraculously, that adds up to 8. Now this is going to be a monster, right? Because you're going to raise 4 to the 5th power, 3 to the third, negative 3 to the 3rd power, so negative 27 times, I don't know what that is, times 56. You will end up with, clearly it'll be a negative 1, 5, 4, 8, 2, 8, 8. Right, that's just the coefficient, and then a to the 5th and b to the 3rd. So that's how you find that term. Lord knows it would be a nightmare to try to do it kind of piecemeal from scratch. So that finishes up today's notes, and hopefully that will help, as always. So we will suspend at this point, and we'll pick up next time.